Hi everyone. So in this video, I will be explaining one more example of this first come first serve algorithm. So I am taking multiple examples so that you can understand this algorithm in a much more better way. Alright. So here I will be showing you the process of scheduling processes. Okay. So at the very first, as part of question, you will be given a set of process IDs, their corresponding arrival times and their corresponding burst times. Okay, just like this thing. Alright. So your next task will be to prepare the Gantt chart. So once you have the Gantt chart, now you can prepare this table very easily. So once you have the Gantt chart and you have successfully prepared this table, what will happen? You will be able to answer all the possible questions. Alright. So from this example onwards, we will start seeing this schedule length and the efficiency as well. And I will be showing you this throughput as well. Alright. Everything will be super clear. Now let's move to the example. So in this example, I have not filled this table and I have not prepared the Gantt chart beforehand. Okay. So that I can do that in front of you so that you can follow it in much more better way. Alright. So let's say this is the CPU. From t equal to 0, the CPU is started. Okay. Fine. So again, one more thing, that this is the relative time with the CPU start time. Alright. So this thing says if your CPU started at 10 AM, alright, then this process P1 has arrived at 10 and 2 am. Alright, this is the second. Alright, fine. So let's start doing this Gantt chart. So at time t equal to 0, CPU started. So first process is arriving at time t equal to 2. So 0 to 2, your CPU will be idle. Okay. At time t equal to 2, in the ready queue, process P1 has arrived. What your OS will do? Your OS will be scheduling this P1. Alright. This P1 will be scheduled. And what is the burst time? That is 4. Up to 4, this P1 will be keep on executing. So by the time t equal to 4 has arrived, if you see, this process 2 and process 4 both have already arrived. So process 4's arrival time is 3. So this will arrive early, and then process 2. Alright. This is a ready queue that your operating system is maintaining. Okay. Now your operating system will be scheduling this P4. Alright. P4. P4's burst time is 3 unit. That means up to 7. So by the time 7 comes, by that time your P3 has also arrived. Alright. Now P2 is scheduled. What is the burst time of P2? That is 2. That is up to 9. Okay. P2 will be running till 9. Then only one process is pending, that is P3. P3 is scheduled at 9 and P3's execution time is 8 units. Okay. So 9 plus 8 is 17. Alright. Now let's fill the table. This will be very much easier once you have the Gantt chart. What is the completion time of process 1? Process 1's completion time is 4. Okay, let me change the color. So this is 4. Alright. What is the completion time of process 2? That is 9. What is the completion time of process 3? Process 3. Okay. So that is 17. What is the completion time of process 4? That is 7. Alright. What is the turnaround time? Do you remember? Turnaround time is the completion time minus arrival time. All good. So now let's compute this this turnaround time. So let me change the color. Turnaround time is this completion time minus arrival time. Alright. So 4 minus 2 is 2. 9 minus 4 is how much? 5. 17 minus 6 how much? 11. 7 minus 6 how much? 4. Okay. So we know another formula, that is turnaround time equal to wait time plus burst time. Alright. Now wait time has to be turnaround time minus burst time. So let me change the color again. So turnaround time minus burst time, that will be your wait time. Okay. So this is 0. This is 3. 5 minus 2 is 3. This is 11 minus 8, that is 3. That is 4 minus 3, that is 1. Alright. Now let's see the response time. So response time is the time duration between the time when your process has arrived, okay, arrival time, and the time when your process is first time scheduled. Okay. At this time your process is scheduled for the first time, and this is the arrival time. So this is the response time. So fine, when this process P1 has arrived at time t equal to 2. Okay, let me change the color again. At time t equal to 2, your process 1 has arrived. When it is scheduled for the first time at t equal to 2, so response time is 0. Alright. So process number 2, when it is arrived at time t equal to 4, when it is scheduled time t equal to 7. What is the difference? 7 minus 4, that is 3. Alright. So coming to process 3, when it is arrived at time t equal to 6, and when it is scheduled for the first time, that is 9. So 9 minus 6 is equal to 3. So again, when this P4 has arrived at time t equal to 3, when it is scheduled for the first time, that is 4. 4 minus 3 is 1. So now we have calculated this Gantt chart, alright, and the table as well. Fine. Now let's move to the second thing. So far whatever we have seen, we have not calculated two things or three things. One is CPU efficiency, another one is schedule length, another one is throughput. So what is the formula of CPU efficiency? CPU efficiency says the schedule length minus idle time. Idle time, in this example your CPU was not idle. Okay, I will come to this later. So as of now just get the formula. CPU efficiency is the schedule length minus idle time, okay, and divided by schedule length multiplied by 100%. All right, then what is the schedule length? Schedule length is across all the processes what is the maximum completion time minus across all the processes what is the minimum arrival time. Again I will come to the schedule length with the examples. So throughput is number of processes by schedule length. So in this example now let's calculate this CPU efficiency. All right, so CPU efficiency is what is the schedule length? Okay, before that let me calculate schedule length. Okay, schedule length. So across all the processes what is the maximum completion time? Okay, 17 across all the processes, 17 is the maximum completion time, and across all the processes what is the minimum arrival time? That is 2. All right, so your schedule length will be 17 minus 2, that is equal to 15. All right, now let's calculate the CPU efficiency. Okay, CPU efficiency, what will be that? Schedule length is how much? 15. So in your schedule length there is no idle time. All right, so from this point your schedule is started, and if you see there is no time when your CPU was idle. Every second your CPU was doing something. So this idle time is how much? In this example is 0 divided by how much? Schedule length. Schedule length is 15. So that is 100%. Though in this example this IO is not considered and the context switch time is not considered. So that is why we have received this CPU efficiency to be 100%. But in practice this is never possible. All right, in future we will be seeing such examples as well.